Today, let's take a closer look at the iPhone 15 Pro. Did you know that the glass on the back of the phone has a grid pattern behind it? I assume this is how they achieve the painting process known as color infusion. The top side of the glass has a sandblasted finish, though I suspect they used a laser to make it so precise. The overall result has remarkable depth, impressive. The small gap between the glass and the titanium frame contains trapped dust, which is no surprise given that this phone has been in service for 3 years. The edge of the camera plateau looks sharp, though I found a tiny imperfection at the top. The flash diffuser is located below. Thanks to the stereo effect, we can see both the frosted glass texture and the dust behind the diffuser. The rear microphone opening has something at the bottom. I hope this isn't a dirt clog, but rather a protective membrane. Here's how it looked before I carefully cleaned it with a fine brush. Because of the dust, we can see both the top and the bottom of the glass. The telephoto lens located above the microphone traditionally contains microscopic dust inside. As with the iPhone 17 Pro from the previous video, the amount and size of this dust are normal. However, the most polluted component is the main camera. Look at this dense cloud of microscopic particles. Something in the manufacturing process of the main camera exposes it to dust more than the other cameras. This was also true of the 17 Pro. The macro camera has much less dust, perhaps because its manufacturing process is simpler. Feel free to correct my assumptions. The front camera is no exception and also contains particles. Have you seen the touchscreen sensor grid in my previous video? They are similar, but I captured a better shot this time with more depth. To achieve this, I took 4 focus stacks at 5-degree intervals and animated them in a loop to reveal the touchscreen grid overlaying the subpixels. The ear speaker gap is covered with debris. I tried my best to clean it using a delicate brush, and this is the result. Not perfect, but at least it looks clean from afar. It has a protective plastic perforated cover at the bottom, similar to the one on the 17 Pro. In low light, we can see the magical blue tint of the front camera. The right edge of the screen reveals its multi-layered complexity. The gap between the screen and the frame is also filled with debris. The side button fits neatly into its socket, with all edges sharp and precise. Below it lies a 5G antenna window made of frosted glass. There is no SIM card slot. Flipping the phone to the opposite side reveals the action button and volume buttons. At the bottom of the phone, we can see what is probably the only scratch it has, located across the plastic antenna gap. The USB-C port is marked with the model number and assembly location. Oops, another scratch on the port. Hopefully that's the last one. The pentalobe screw makes me wonder, should I unscrew it? And here are the perfectly clean bottom speakers. What, not perfect enough? Just look at how they were before. So, I unscrewed the screw. It was unexpectedly difficult for a first-timer, especially finding the right tool. Luckily, I had a star-shaped 0.8mm screwdriver, also known as a P2 pentalobe. My next logical step was opening the phone. I have zero experience, but I took the risk. I bought this tool specifically for the video, though it had to be heavily modified before it worked. It was flimsy, so I tightened all the screws. The blue pads were too soft and couldn't hold the phone in place, so I replaced them with slimmer, harder pads. They also forgot to add padding for the head of the phone. The clamp wouldn't stay in place and lifted with the phone, so I fixed it using woodworking clamps. Finally, I added a blue plastic gasket so the screw could rotate instead of drilling. After all that trouble, voila, the guts. The variety of screw heads is impressive, each one different. I exaggerate, but seriously, why? What if I want to open the logic board? A new screwdriver each time? I was not prepared for that. They are beautiful though. And here's the even crazier part. They're also different in length. You actually need a screw map to avoid damaging the board. And don't forget about the different tightening torques too. The Face ID module, hidden behind the dynamic island cutout, consists of an infrared floodlight illuminator that allows the phone to see you in total darkness, a dot projector, which casts invisible infrared dots onto your face to create a precise depth map, and an infrared camera, which captures this dot pattern. To the right sits the front camera, and above it, the earpiece grid. It is surrounded by adhesive, which I previously dissolved with alcohol to open the phone. The adhesive itself looks mesmerizing. The gap between the screen and the frame has collected a lot of debris. Here we can see microscopic blue plastic shavings from an unsuccessful attempt to pry it open with a plastic tool. These strange silver bands under the main camera module are thermal conductors that cool the camera when in use. Below, we can see the corner of the battery, and to the right are the internal mechanics of the power button. Along the edges are gold-plated pins that make contact with gold-plated pads on the screen, providing additional grounding for static electricity protection. There's also leftover adhesive clinging to the screen. The dynamic island cutout behind the screen reflects light oddly, probably due to a special coating. The front camera area looks dusty, though most of the particles are on the outer surface of the screen. Below the screen are neatly organized deposits of gold, intended for Apple's screen testing and diagnostics. For the next step, we need a tri-point screwdriver. It's even smaller than a pentalobe, measuring just 0.6 mm wide. This tool allows us to unscrew the logic board cover and access the component connectors. The screw itself is so tiny that I was afraid I might inhale it by accident. Compare its size to a safety match lying nearby. Under the cover we can see two types of standoff screws and several snap-on connectors. All the sensitive electronics are hidden on the opposite side, sandwiched between two boards, and unfortunately require soldering to access. If you're interested in how I make my videos, join my 10x members area to watch my workflow in detail. Same on my Patreon. After disconnecting the display, the gold-plated contacts of the display port become visible, along with a nearby gold-plated logo. The volume button, previously concealed behind the display, now reveals its internal mechanism. Watch the movements of the action button's mechanics inside. These rows of dots are marks from a high-precision process known as laser spot welding, designed to join miniature components instantly without transferring damaging heat. To the right, we can see the sensor port I just disconnected, since its flex cable is attached to the display. This single connection houses two crucial components: the ambient light sensor, which controls true tone and auto brightness, and the proximity sensor, located under the dynamic island, which dims the screen when you hold the phone to your ear. And this is how the edge of the screen looks from the side. The pentalobe screw fits directly into this hole to secure the screen in place. And that's it. Thanks for watching.